Hi, I'm James Verdier, and welcome to the American Institute of Biological Sciences BioScience Talks, which is a forum for integrating the life sciences. On the second Wednesday of each month, and often in between, we discuss the latest bioscience publications. And as a reminder, if you'd like to read more, point your browser to academic.oup.com/bioscience. For this week's episode, I'm joined by Dr. Alex McIntuff, who's a postdoctoral researcher at the University of California, Santa Barbara. He joined me to talk about fences, and in particular, fence ecology. I'll let him explain. Dr. McIntuff, thank you very much for joining me today.
Thanks so much, James, for having me here.
Okay, so we're going to be talking about fences, and they've been studied to some extent, but there isn't necessarily the same sorts of broad consensus on their impacts on wildlife, et cetera, as there have been for other landscape features. And I'm just wondering, what contributes to that? I think our listeners will have heard about, roads and their effects on wildlife movement and those sorts of things. But what makes fences different or more challenging?
It's a great question, and in some senses, fences have received a lot of studies. We reviewed 446 studies in our review. But in another sense, as you mentioned, there hasn't been a big consensus or a set of broad lessons that have connected the dots between all of these diverse and somewhat siloed studies. And it's good that you mentioned roads because we thought a lot about roads in putting this research together. And roads were in a really similar position in the 1990s. Back then, roads were so ubiquitous. Much of the world's population probably saw or spent time on a road on any given day. And yet they were so common that they almost drifted into the backdrop until the late 1990s, when a body of research came together and started examining the ecological effects of roads and started pulling all of those diverse studies together into a bigger set of broader lessons about roads. And what this research found was that the effects of roads are much, much bigger than their actual footprint on the landscape, and that they have a broad suite of effects at multiple scales and of multiple kinds that were really not being revealed by any individual study. And that body of research became a discipline called road ecology. And so we were sort of inspired by that to take fences from this part of the backdrop, part of the landscape that's so ubiquitous you almost don't even see it, and say, okay, what do we actually know? What are the broader lessons from looking at all this literature together? And what are fences actually doing to the world that we live in?
Okay, and I guess that raises the obvious question then of what kinds of things are fences doing to the world that we live in? And, also, to some extent, what kind of fences are they? Are we talking about, a little bit of a wire with some pickets every 3 feet, or are we talking about, a highly built 12-foot tall, chain link type of fence? Kind of how does all that come into play?
Yeah. So I think, probably what receives the most attention to someone who's not like me studying fences out there are border fences. We hear a lot about those in the news. They're rapidly expanding around the world. And they can be really elaborate constructions, but they represent a really small fraction of the fences in the world. And the same is true of conservation fences, which are another kind of well-known type of fence. So probably the most abundant type of fence in the world is a livestock fence. And a livestock fence is typically just a few wires strung between posts. But yeah, as you mentioned, the elaborateness of a fence can range from that all the way up to some of these towering, imposing border structures that you see in the news. I think a key distinction is, we did try to draw boundaries around what we were studying and say, well, we're not talking about walls. We're not talking about medieval ha-has. We're looking at structures with kind of intermittent structural posts and kind of wires or semi-transparent or permeable structures stretching between them.
That makes sense. And I have to ask, what's a medieval ha-ha?
That's great. Yeah, we had a lot of fun kind of looking up what the not quite fences of the world were, and so it's sort of like a ditch that was used as a defensive structure in medieval times, but it's got a great name. So.
Okay, thank you. Yeah, that was an absolutely necessary aside. I had to know that before we could possibly move on. So, what sort of broad effects of fences are you seeing then? Just to characterize those and then to talk about what more broadly based lessons we can learn from them. But what sorts of things do we typically see?
Yeah, that's a great question. And the way this question is often posed to me is, what are the good fences and what are the bad fences? And what we found is that that's actually not a great way to think about the ecological effects of fences. And instead, the biggest finding that we offer in our research is that every fence creates a set of winners and losers, ecologically speaking. So there's no good or bad fences, but they all create winners and losers. And when we looked through the literature, we found some broad patterns in terms of what kinds of species and ecosystems tend to be winners and what kind tend to be losers. We found that generalist species, disturbance-loving species are often winners, whereas more specialized species and ecosystems tend to be losers. And unfortunately, that's consistent with the effects of a lot of types of infrastructure in the world. So fences are kind of adding to this pattern of filtering that's already happening from a lot of types of infrastructure. When we kind of look at this more broadly, what we find is that fences tend to create more losers than winners. And so what that means is that as fences become more dense or as they begin to proliferate rapidly, you kind of get what we've termed ecological no man's lands, where because there's more and more losers than winners, fences create ecosystems where only a narrow range of traits or ecosystem characteristics can survive and thrive, and a lot of others are pushed out. And there's mounting evidence that at high enough densities, with enough fences proliferating rapidly enough, this can actually lead to meltdown or collapse of whole ecosystems.
So it's a case in which you have fences that are excluding enough specialist species that just a matter of the density is high enough that you no longer have the sort of assemblages that you would want to see in a healthy ecosystem.
Yeah, for the case of total ecological collapse or meltdown, that's true. But even in areas where fences aren't dense, you still get this pattern of fences generating winners and losers, and that reorganizes ecosystems even if it doesn't cause them to collapse.
Let's drill down and maybe just take an example of, say, out west, a wildlife fence, for example. What kind of species can get past the fence? What kind of species can't get past the fence? And what happens to an example? It can be made up ecosystem somewhere out there on the range.
Sure. Well, I'm going to take a little time to answer this question because there's another important part of our study that I want to mention in answering it, and that is that there's been a big bias in the literature on fencing that looks at how they affect animals in particular and how they affect animal movement even more specifically. That's been a huge bulk of the number of studies on fencing. And so what we found was that when we took a broader look, fences actually affect multiple other scales of ecological pattern and process. So from really kind of tiny scales, like affecting the way in which spiders build their webs or creating habitat for generalist bird species, all the way up to these kind of continental processes. If you look at the dingo fences in Australia, which are arguably the longest man-made structures in the world, there's evidence that they are initiating trophic cascades and other kinds of ecological processes that are changing ecology at a continental scale. So yeah, I can give you some examples of specific species or movement, but I think it's also important to point out that this is a kind of multi-scalar and multifaceted set of processes that we're talking about here. So, maybe sticking with Australia for an example, Australia is kind of famous in the fencing world for erecting fences that keep invasive species from invading. And we know that a lot of invasive species are successful because they are these generalist species or disturbance-loving species. So we found a particularly ironic case where cane toads, one of these famous invaders of Australia, are actually using cleared fence lines as a kind of highway to facilitate their invasion. Elsewhere in Australia, fences that were set up to be conservation fences, we actually found some examples in which they were having really devastating effects on the species that they weren't designed to protect. And in particular, reptiles seem to have it bad around the world, probably because they either have to crawl under or crawl over fences, and thus are more prone to get entangled or electrified if it's an electric fence. So those are just some examples of how, even good fences can produce losers, and sometimes fences have ironic consequences, tend to favor invasive species.
So that's a case in which you've built this fence very specifically to perform an ecological good, as one might say, and you wind up having all these perverse outcomes. Is there a way to figure out if they're worth it, or is it just you kind of have to look at everything and try to come to a conclusion?
Yeah, it's such a good question, and I think it kind of gets back to our point that it's hard to say, or it's hard to classify a fence as exclusively good or exclusively bad. Fences are often a management tool that land managers use, and so by nature they kind of have to have targets or goals. And so what one of the findings of our research is that there's been a fair amount of studies that have looked at the effects of fences on target species, but there's been a much fewer number of studies that have looked at their effects on non-target species. And so even those, quote unquote, good fences may have a number of ecological effects that we don't understand because they're affecting species that aren't the targets of management. But getting to the other part of your question, I think when we start to think about fence policy, there's two things to think about. The first is that we need a lot more research, and that's one of the things that our paper calls for. But we also know enough now to start taking policy action. And we have some recommendations for policy in our paper, but any kind of policy would have to be context specific and work with some of the frameworks that we provided to think about fences in their ecological context, the multiple scales at which they work, and what interventions might be available.
What kinds of things are policy or fence-related policies not taking into account right now that they should? What sorts of things should feed into the decision of whether you erect or take down a fence? Where are policymakers being inadequately informed at this point?
If there were a kind of broad set of fence policies, I think that would be a good start. But often there just really aren't ones at all about them. But that's starting to change, and that's really good. And so we have some positive examples that we can look at. So one really maybe low-hanging fruit in the policy world would be to look at the way that fences are designed. We can take that big body of literature on the movement of animals and the effects that fences have on that movement, and think about how to design wildlife-friendly fences. This is something that I know is becoming popular in places like Wyoming and other areas in the Rocky Mountains where there's a lot of migratory species. And managers and researchers there have found that really subtle design changes to fences can actually really positively benefit animals and allow them to cross the fences more easily without any big costs to the utility that fences are serving. So that's one. And then I think we can think about bigger scale, the way fences are aligned, starting to plot them along natural transitions or boundaries in the landscape, as opposed to kind of putting them up where it's more economically or logistically convenient, is another. But then, as we talked about in our paper, there are some bigger policy actions that I think could be really powerful that are a little bit more challenging, which involve pulling fences down or deciding not to build them in the first place. And we can talk about what that would look like.
And what would that look like? What's the process like right now? And, what should the process look like? Is there any kind of, environmental impact being evaluated before your average fence is put up, or is it, simply at the landowner's prerogative?
Yeah, it really depends where you are in the world. I think it differs a lot in different countries and regions. But I'd say one really important consideration is that we touch on this in our paper, but we don't go into depth, that a huge missing piece of a future discipline of fence ecology right now is understanding the kind of sociological, economic, and political entanglements that fences are involved with. Fences are an economic reality and necessity for a lot of different people and industries, and so any policy that addresses them is going to have to engage with that in a deep way. So that's an important point to make. But let's say you could do that and think about that and decide that it's a good idea to take down a fence in a particular context. There's There's a lot of derelict fences. Fences are often erected, but they are quite difficult to maintain. And so there's a lot of fences out there that are kind of sitting, rotting, or rusting on the landscape. And so we've kind of continued to encourage a plucky NGO or agency out there to set up a program to start taking down some of these derelict fences that aren't serving any kind of economic function at the moment. And that would do a lot of good. But we also know that this is kind of fascinating. Even when fences have been removed, their ghosts tend to linger on. And so animals and ecosystems tend to kind of preserve the boundaries and impacts that those fences created even after the fences are removed. And so that's just a piece of evidence to suggest that when possible, not constructing fences in the first place or having a really clear set of goals and aims in doing so is kind of a key consideration.
The ghost fence phenomenon, is that a result of behavioral changes related to memory and just the patterns that the animals there have taken, or are we talking about some sort of physical change on the landscape that persists even after you pull the fence itself?
Yeah, I'd say it's a phenomenon that needs more research to really be able to answer that question in full, but it appears to be related to both of those things, animal animal memory and the kind of physical changes that fences have created in the landscape that continue to be respected by the animals living there.
And one thing I was hoping we could touch on just really quickly, but the ubiquity of fences, the number of fences. It struck me in looking at one of your maps of fence density, and I had been last year hiking in an area that I thought was the middle of nowhere. I was out on remote BLM land, and I assumed there was nothing human made within miles of me, at least in a couple spots. But no, I was in a red zone where it was impossible to get a kilometer away from a fence. Apparently, there are quite a few fences. How big is the scope of that situation?
Yeah, it's really hard to say with specificity. One of the challenges in studying fences is that unlike roads, we haven't really been able to marshal the advances in remote sensing and satellite imagery and all of these things to start detecting the global scope of fences like we have been able to do with roads and other pieces of infrastructure. Fences are simply a little bit hard to see from space. That being said, there have been a few studies that have tried to measure the density and extent of fences and compare that to roads. And in some cases where they've done so, they've found that the length of fencing outstretches the length of roads by an order of magnitude. And if that were true across the world, then we would start measuring the total length of fences in astronomical units, because they would, if you stacked them end to end, would stretch to the sun and back multiple times. So in all likelihood, fences could be the most prevalent form of human infrastructure in the world. But again, as you mentioned, your anecdote's a great demonstration of this. We really don't have a clear picture of how that patterning looks in space. So one of the things that we tried to do in our paper was take a look at the Western U.S. This place that you described is kind of famous for having a lot of areas that are pretty low development or seemingly remote, and we tried to estimate the density of fencing throughout these areas. And what we found is that a number of areas that are supposedly really low in terms of their human footprint actually have pretty high densities of fencing. And so in all likelihood, those are areas that are really rapidly changing or have undergone a large amount of ecological change that hasn't really been adequately picked up or addressed. The last statistic I'll throw out there is, referencing a famous arachnologist from the 90s who said, "You're never more than 3 feet from a spider." So we tried to make that calculation for the US and found out you're basically never more than 3 kilometers from a fence. So yeah, your anecdote is really true to our calculations.
That's really, really interesting. One question that I always ask is what I just think of as the climate change question. In this case, I'm imagining species that have to adjust their ranges in light of climate change. Will fences make that more difficult, or is that an obstacle?
Definitely. I think we know of all the things that we know really clearly about fences, it's something about their impacts on animal movement. And so we know that for species with really large range sizes who are likely to encounter fences very frequently, We know that they change their behavior around fences. Even fences that animals like deer can cross, they'll often take long detours to go around them. Um, when they do cross, there's a risk of injury or entanglement. We've seen that a lot of ground nesting birds, you wouldn't think of a bird as being particularly impacted by fences, but there's a lot of studies that show that ground nesting birds actually have pretty high mortality rates from flying into fences. So there's a lot of effects on animal movement that we can cite from the literature that would work in conjunction with climate change to have some pretty serious effects. But then there's also looking at bigger ecological scales. I think there's a lot of unknowns about how fences interact with all of these other ecological processes and how those scale up, and what those might mean. And that's the kind of research that we need going forward.
Absolutely, and we'll look forward to it. I might ask, what's next for your research in particular? What are you looking at now or in the future?
Yeah, I'm one of these newfangled interdisciplinary scholars. So in this paper, I was kind of looking at how humans fit into ecology, and now I'm kind of looking at the other side of the coin. So I'm looking at some of the social conditions and questions around the possible reintroduction of grizzly bears to California.
Oh, that's an interesting idea, and sounds quite exciting. We'll look forward to it. Thank you very much for joining me today.
Thanks so much, James.
And that concludes this episode of BioScience Talks. Just a reminder, the journal BioScience is published by Oxford University Press on behalf of the American Institute of Biological Sciences and is made possible by the support of our members and donors. Thank you, and talk to you next time.